Good evening, students. This is the lecture number 4 on a reflection of light. The important question already we have discussed in the last lecture. This is the last topic of reflection of light, which is linear magnification. Very simple topic. What is the linear magnification? The ratio of height of image formed by a spherical mirror to the height of the object is called the linear magnification produced by the spherical mirror, and it is denoted by small m. Clearly we have the formula m equals to h dash upon h, okay, where h dash is the height of image and h is the height of an object. Okay, see the figure which we have took in the last derivation, and that is mirror formula. Okay, here we have the same figure. The object will be the object is considered beyond the center of curvature. Okay, so we get the image in between principal focus and center of curvature. A real and inverted image is small in size as compared to the object. Okay, in the figure we have here we have two right angle triangles. First one is the ABP. See in the figure, this is your ABP. Okay, and second one is what? A dash B dash P. Similarly, which we have considered in the last figure, last derivation. Okay, now applying the sign convention, AB is the height of an object and A dash B dash is the height of an image. Okay, so A dash B dash equals to minus h because the height of an image measured downward, and AB is your height of object. This is positive because measured upward. PA is nothing but the distance of an object from the pole measured against incident ray, that is minus u. And the next one is the PA dash equals to minus v, image distance measured against incident ray. Okay, you can see in the figure. Okay, so equation, we have the equation. What is the equation? A dash B dash upon AB equals to PA dash upon PA. This is your equation number 1. So put the value in, put the respective values in the equation number 1. So after putting the values, we get minus h dash upon h equals to minus v upon minus u. Minus and minus will cancel out. So we get h dash upon h equals to minus v upon u. Okay, what is the linear magnification? M equals to h dash upon m. So m equals to h dash upon h equals to minus v upon u. This is the formula to find out the linear magnification. Okay, so here we have some important conditions. When the value of linear magnification m is greater than 1, then the image form is enlarged image. You get the enlarged image. Okay, when the value of linear magnification less than 1, then the image formed is diminished image. Okay, next one is when m is positive, image must be erect, that is virtual. Okay, if the value of m is positive, the image must be erect image or virtual image. Okay, next one is when m is negative. If the value of m is negative, image must be inverted, that is real image. Okay, and in case of convex mirror, m is positive only. Okay, जब भी आप कॉन्वेक्स मिरर कंसीडर करेंगे, हमेशा आपका जो m का वैल्यू रहेगा, इट इज़ ऑलवेज पॉजिटिव. ओके, so keep in mind these important points which I have written here. Okay, so these are important for your objective questions and also JEE and NEET like exams. Okay, okay, so this is the end of the reflection of light through the spherical mirrors. So there are some important uses of a spherical mirror. First one is the convex mirror is used as a reflector in street lamps to diverge the light over a large area. Okay, So, next one is convex mirror is also used as a rear view mirror or driver's mirror in vehicles because it has a wider field of view. Concave mirror is used as a reflector in searchlight, headlights of vehicles, etc. And a concave mirror is also used as a face looking mirror because it forms erect and magnified image. And spherical mirror are also used as a trick mirrors. Okay, so these are some important uses of spherical mirrors. So this is the end of our reflection of light topic. Next we are going to discuss the second phenomena of light, that is refraction of light. Okay, welcome back students. We have discussed about the reflection of light, and now we are going to discuss the next second phenomena of light, that is a refraction of light. Okay, so what is the refraction? Okay, refraction involves change in the path of light due to change in the medium. Okay, जब हमने रिफ्लेक्शन की बात करी थी तो उसमें हमारे पास में एक प्लेन सरफेस था जहाँ पर लाइट इंसिडेंट होगा और सेम मीडियम में क्या हो जाएगा, वो रिफ्लेक्ट हो जाएगा. दिस इज कॉल्ड द रिफ्लेक्शन ऑफ लाइट. बट इफ़ वी हैव अ ट्रांसपेरेंट मीडियम, ओके, अगर हमारे पास में कोई ट्रांसपेरेंट मीडियम है और एक लाइट बीम उसमें एनकाउंटर हो रहा है उस ट्रांसपेरेंट मीडियम में, so there are three types of events can be occur. Okay, so at the point of incident we have red. See here, we have red. R stands for reflection. Some part of light will be reflected through the surface, some part of the light will be absorbed. A stands for absorption. Okay, some part of light will be absorbed by that particular surface. And next one is the transmission. Okay, if we have the transparent medium, then rest of the part of the light will be transfer or transmit through the medium, another medium. Okay, so at the point of incidence we have red. R reflection, A absorption, T is the transmission. Okay, okay, see the figure. This will be your incident ray, this is your reflecting rectangular surface, this is the point of incidence. At the point of incidence there is reflection of light, so this is your reflected ray. Some part of the incident ray will be absorbed by this particular surface and rest of the part will be transferred through the another medium. Okay, so this is your reflected ray. Okay, so when a beam of light encounters another transparent medium, a part of light get reflected back into the same medium, while the rest enters the other. Okay, the direction of propagation of an obliquely incident ray of light that enters the other medium changes at the interface of two media. This phenomena is called the reflection of light. Okay, so after reflection ये जो आपका refracted, this is called the refracted ray, तो ये जो आपका रहेगा ये एक्चुअल जो पथ फॉलो करना चाहिए इस पथ को फॉलो कर नहीं करेगा और ये क्या करेगा, अपने ओरिजिनल पाथ से डाइवर्ट हो जाएगा. ओके, so this phenomena is called the refraction of light. Okay, this particular phenomena is called the refraction of light. Clear? Okay, so for your notes you can write this definition. Okay, refraction of light. You can take a screenshot to maintain your notes. Okay, next one is the law of refraction. जैसा कि हमने देखा था रिफ्लेक्शन ऑफ लाइट में हमारे पास में दो लॉज थे. सो सिमिलरली हियर वी हैव टू लॉज ऑफ refraction. Okay, so first one is the incident ray, refracted ray, and the normal. to the refracting surface. Okay, this will be your normal, this is your incident ray, this is your refracted ray to the refracting surface at a point of incidence, all lie in the same plane. Okay, all lie in the same plane. Okay, this will be your first law of refraction. Okay, next one is the ratio of the sine angle of incidence to the sine angle of refraction is constant for two given media. This constant is denoted by mu. Okay, and is called the refractive index. Okay, is called the refractive index. So mathematically sin I upon sin r equals to mu. Okay, you can see here I is your angle of incidence, r is your angle of refraction. So sine of angle of incidence to the sine of angle of refraction is equals to mu. Mu is what? Mu is your refractive index. Okay, so here we, since here we have two medium, first one is medium 1 and second one is medium 2, it both are different mediums. Okay, so here if the medium 1 is A and medium 2 is B, so the refractive index is written as A mu B. Okay, A mu B. So A mu B is called the relative refractive index. What is a relative refractive index of the medium? Okay, so relative refractive index of medium B with respect to medium A. Okay, relative refractive index of medium B with respect to medium A. Okay, or it can be written as mu B upon mu A. Okay, mu B upon mu A. This is also called the Snell's law of refraction. This law is also called Snell's law of refraction. Okay, the very important law. Okay, now come to the refractive index. What is refractive index? Refractive index जो भी होगा वो किसी मटेरियल का होगा. Okay, so the refractive index of a material is what? It is the ratio of what? So it is the ratio of speed of light in the vacuum and speed of light in the material. Okay, the ratio of speed of light in the vacuum to the speed of light in the material. Okay, so mathematically it can be represented as mu equals to C upon V. Okay, refractive index, mu is the refractive index, C is your velocity of light in vacuum, and V, this is your small v, V is the speed of light in any medium or any material. Okay, mu is called here the mu alone is called the absolute refractive index of the substance. Okay, mu is what? Absolute refractive index of a substance. But if I write A mu B, so it is what? It is the relative refractive index because it relates both the mediums. Okay, so what refractive index tells? Okay, it tells us कि सपोज दैट अगर कोई रे एयर में ट्रैवल कर रहा है तो वो कितना स्मूथली उस मीडियम में ट्रैवल कर सकता है, और अगर रे एयर को चेंज करके अपने मीडियम को चेंज करके किसी अनदर मीडियम में जा रहा है, इट मे बी ग्लास, इट मे बी वाटर, इट मे बी ऑयल, टर्पेंटाइन और एनी अदर ऑयल. ओके, सो उसके कंपैरिजन में कितना उसके मूवमेंट में हमें फ़र्क मिलने वाला है. ओके, सो दिस विल बी गिवन बाय relative refractive index. Okay, here we have some different mediums, substance mediums, and their relative index. For ethyl alcohol we have 1.362 as a refractive index, for water 1.333, for air 1.000293, and for oxygen 1.000271. Okay, next one is the relative refractive index. As I discussed earlier, It is a measure of how much light bends when it travels from one medium to another medium. रिलेटिव रिफ्रैक्टिव इंडेक्स हमें ये बताएगा कि जब आपका लाइट एक मीडियम से दूसरे मीडियम में ट्रेवल कर रहा है तो वो किस अमाउंट में बेंड हो रहा है. ओके, सो हियर वी हैव टू कंडीशंस. If the angle of incidence is greater than angle of refraction, okay, that means if the light enters from rarer medium to denser medium, it bends towards the normal. This will be your normal. Okay, it bends towards the normal. Whereas if the light is enters from denser medium to rarer medium, that is your angle of incidence is always less than angle of refraction, then the refracted ray always bent away from the normal. Okay, कैसा होगा ये? Away from the normal आपका ये bent होगा. Okay. Okay, next one is the principle of reversibility of light. Just you have to write the statement: when a light ray, after suffering number of reflections and refractions, okay, has its final path reversed, it travels back along its entire initial path. This is called principle of reversibility. Okay. You can understand this principle of reversibility with the help of this diagram. We have one refracting surface. This is medium 1 and this is medium 2. This is the incident ray which is coming through from medium 1 towards medium 2. Okay, so suppose that this is your rarer medium and this is your denser medium. So after refraction, the refracted ray will be bent little bit towards the normal. Okay, so according to the second law of refraction, that is Snell's law, 1 mu 2 relative refractive index is equals to sine of angle of incidence divided by sine of angle of refraction. By putting suppose that if I put one mirror at point B, what happened? The ray will be returned back following the same path. The ray will be returned back following the same path. Okay, so by putting the mirror, what is the relative refractive index? That is 2 mu 1 equals to sin r upon sin I, just opposite from denser to rarer. Okay, 2 mu 1. Okay, so here we have two equations, equation number 1 and equation number 2. On multiplying 1 and 2, we get 1 mu 2 into 2 mu 1 equals to sin I upon sin r into sin r upon sin I. Sin I will cancel out, sin r will cancel out. So we have 1 mu 2 into 2 mu 1 equals to 1, or 1 mu 2 equals to 1 upon 2 mu 1. That is what? That is a refractive index of medium 2 relative to medium 1. Refractive index of medium 2 relative to medium 1 is equal to the reciprocal of the refractive index. Reciprocal of the refractive index of medium 1 relative to medium 2. Okay, clear? Refractive index of medium 2 relative to medium 1 is equal to the reciprocal of the refractive index of medium relative to medium 2. Okay students, so this is the end of lecture number 4. We will continue the refraction of light through a glass slab in our next lecture. Okay, thank you so much.